Now it's time for our big deal, worth $9,452. That's some deal. And the first...
Monty Hall is a famous game show host. He started the program Let's Make a Deal in 1963. He offered 3 different doors to contestants. They had to decide which door to take. And to take a door, they had to give up some valuable prize. There are many YouTube videos about Let's Make a Deal and the strategy that contestants should use. I've looked at many of them, and they're all graphically oriented. What I want to do is to use simulation to look at this problem. I will be using SIPmath. We will develop the model and look at the traditional way that Monty Hall would follow decision policy. We'll then look at some alternative ways and see how that changes the probability for the participant to win the big prize. The Let's Make the Deal television show was really one great big advertisement with gifts provided by these types of companies. Here's the model I want to share with you. Initially, it describes the problem which we've talked about already with the 3 doors, and the participant picks one and then given an opportunity to switch, and what should they do. Like a newspaper article, let's look at the bottom line and where we're going. Here is the distribution in blue showing the probability of ending up on each one of these doors, 1, 2, or 3, if the participant doesn't switch. And as you might expect, it's a 33% chance of winning if the car is behind door 1. And in this model, the car is always behind door 1, and then the participant randomly selects 1, 2, or 3 doors. Now, if the participant always switches, that probability of ending up with door 1 is shown to be 66%, 2/3 chance. And then there's a 1/6 chance of ending up with door 2 and a 1/6 chance of ending up in door 3. And this is just coming out of the simulation. So now let's talk about how the model is put together. We have to start with what the participant selects. And they can pick 1, 2, or 3. And in this case right now, the participant selected door 2. Monty Hall then shows a door. He would never show the car, so he'd never show door 1. He'd either show, in this case, he's going to show door 3 because it's the only other door that doesn't have a car, and it's not selected by the participant. Then, if the participant decides to switch, he could only switch to door 1. He wouldn't switch to a goat door like 3. So let's look at a different simulation here. We'll go to trial information and go up to another one. So here the participant selected 1. Monty showed him door 2. They always switched, so they went to door 3, so they got a goat. Here, this is the 2, 3, 1 again. Here's a 1, 2, 3, 1, 3, 2, 3, 2, 1. So the model is saying what did the participant select, what did Monty Hall show, and then which door was selected. The logic used for Monty Hall's decision policy is given by this table. So if the participant selected door 1, there's a 50-50 chance that he would show door 2 or 3. If the participant selected door 2, he cannot show door 1 because that has the car. He can't show door 2 because of what they selected, and so he must show door 3. And if the participant selected door 3, he must show them door 2. The model then makes a selection of these 3 probabilities based on what was selected by the participant, and then we're going to discretely decide which doors to select using this equation up here. To get the door that's selected by the participant when they switch, we simply use the first term here, 6. That's the 1 plus 2 plus 3 minus the other two doors, and that's what the one that's remaining. We'll use this later on when we look at the alternative decision policy. And that's really all there is to the model. All we need to know is what was the final selection, and this is the variable, the random variable that's being plotted down here. So now let's look at an alternative decision policy by Monty. What if Monty Hall could also show the door that they selected, forcing them, presumably, to select one of the other two doors? What do you think the probability is? So what I'm going to do is I'm going to change this to the alternative view. What happened here? If they select door 1, he's got a 50-50 chance of showing door 2 or 3, and that's true no matter what door they select, he will pick door 2 or 3 to show them. In this case, we can see that the probability of getting the car is only 50%. So by using simulation, we were able to evaluate different decision policies of Monty Hall. We could change the game, and we easily get the results. We don't have to run through a lot of math or figure out some slick ways of portraying the problem. So I'm hoping you find this useful. Thank you very much for watching.